We're talking about Chapter 5, Section 1, perpendicular and angle bisectors. So perpendicular bisectors and angle bisectors. Your objective is to prove and apply theorems about perpendicular bisectors and to prove and apply theorems about angle bisectors. I want you to stop the video, write down your question. Don't forget to look at your depth of knowledge chart in your agenda. First theorem that we're going to talk about is a perpendicular bisector theorem. This theorem says that if you have a perpendicular bisector for a segment, then any point that you choose on that line, that's the bisector, will be the same distance away from both ends of your segment. So they, for instance, chose this line, and it's the same distance here and here to each one of those points. But if I had chosen any other point on the line, so say I chose this one, it would be the same distance between this here and those ends there. The converse of the perpendicular bisector theorem says the opposite, or the inverse of what this one says. This one says that if I have a line and any point on that line is the same distance away from the endpoints, if that's the case, then I can say that this is the perpendicular bisector. And that means that these would be the same distance as well. The first example, you need to find the measure of MN. MN is this unknown measure here. Because we are told that this is a perpendicular bisector, we know that both of these distances are going to be the same. So because of the perpendicular bisector theorem, I can say that segment MN is equal to segment LN. And I know that LN is 26, so I'm going to substitute 2.6. 2.6 for that segment there. And I have segment MN is equal to 2.6. Second example, we have to find the measure of BC. BC is here. I know that this distance from this point to both ends of that segment are the same. They're both labeled as 38. Because of both of these are the same, then I know that this is going to be a perpendicular bisector. So that's a perpendicular line, and it cuts this one in half. Because DC is labeled as 12, I know that BD is also going to be 12. Actually, I should write that down. So BC, this total distance, is going to be 2 times, because this one is the same as that one, this segment here, DC. And that's because it's a bisector. Both of these are the same. And then when I substitute 12 for CD, or DC, I wrote it backwards, I get BC is equal to 2 times 12, which tells me that BC is equal to 24. Example 1C. Now we need to find the measure of TU. I have TU here. That's the one that I'm looking for. They already tell me that this is the perpendicular bisector because it's labeled as 90 degrees, and I can see that both of these segments are equal to each other. Because I know that it's a perpendicular bisector, I can use the perpendicular bisector theorem to say that TU is equal to UV. TU is equal to, oh, you know what? I should have written VU. VU. Alright, then we need to substitute the values. So I have 3x plus 9 is TU, and 7x minus 17 is VU. Then we need to subtract 3x from both sides. That's gone. I end up getting 9 equals 4x minus 17. I need to add 17 to both sides. That's gone. and here I get 26 equals 4x. Divide both sides by 4, trying to isolate the variable. I end up getting x equals 6.5. Now I wasn't looking for x, I was looking for the value of tu. So make sure that you go back and check what your question is asking for. I still need to substitute this 6.5 into that problem. So tu is going to equal 3 times 6.5 plus the 9, and if I do that math, I end up getting 28.5. So that is the value of tu. The next theorem we're talking about is the angle bisector theorem. So if I have an angle that is bisected, so it's cut in half, that tells me that it's bisected, then I can conclude that any point on this line is going to be the same distance to both of the rays that make up the original angle. The converse of that says that if I have a point on the line, or on the ray, that is the same distance to both sides of the angle, then I can conclude that it's the angle bisector and that these two would be the same. Don't forget that when we're talking about distance, we're talking about the shortest distance between that point and the line that I'm traveling to. So it has to be a perpendicular line. You can't just pick a bunch of random lines going to different spots. It has to be the shortest distance. So here's our first example. I have to find the measure of BC. I'm told that this is bisecting this angle here because these arcs tell me that they're the same. This is the distance between from this point on this ray to each one of those two sides. Because it's the perpendicular bisector, I know that this distance is going to be the same as that distance. So I can say that BC is equal to DC, and then I know that DC is 7.2, so I have BC is equal to 7.2, and that's what I was being asked to find. Alright, next one, we have to find the measure of EFH. EFH, so this angle in here is what we're looking for. And we're given that EFG, this entire angle here is 50 degrees. I have that this point on this ray here is the same distance to both of those rays that make up the original angle. Because it's the same distance to both of the other rays, I can use the converse of the angle bisector theorem. To say that these angles are going to be congruent to each other. So I have the measure of angle EFH is going to be half of the measure of angle EFG. And I know that EFG is 50 degrees. So the measure of angle EFH is half of 50 degrees, and half of 50 degrees is 25. So the measure of angle EFH is 25 degrees, and that's what we were looking for. Alright, last one. We're trying to find the measure of MKL. MKL is this angle here. I know that because this point is the same distance from both sides, I can use the converse of the angle bisector theorem again. So converse of the angle bisector theorem to say that these angles are equal to each other. They have the same measure. So the measure of angle MKL is equal to the measure of angle JKM. So now I can set the two values equal to each other. That gives me 3A plus 20 equals 2A JKM. MKL. Alright, I wrote these backwards. 2A plus 26 equals 3A plus 20. And I can subtract the 2A from both sides. This is gone. I get 26 equals A plus 20. I minus 20 from both sides. That's gone. I get 6 equals A. Now I found A, but I wanted, or the directions were asking me to find MKL. MKL, so I need to plug in A to 2A plus 26. So that's measure of MKL is 2 times 6 plus 26. Oops. And then if I do that math, I end up getting 38 degrees, which is the measure of angle MKL. If you have any questions, please write them underneath your summary, and we can talk more about this on Monday.